Hello students, very good morning. Welcome to Narayana live classes. Today for class 9 students, we are going to discuss assignment number 29 on quadratic equation. In particular, today we are going to see few problems on solving rational functions under wavy curve method. Okay, now let us start with the first question. Solve 2 power x minus 4 upon log x base e times of x cube minus 27 greater than 0. That is the question here. Now let us start this. So the function is 2 power x minus 4 upon log x base e into x cube minus 27. So we can write it as, let us take it as f of x. 2 power x minus 4 upon log x base e times of x cube minus 27. So that we can write as 2 power x minus 4 upon log x base e. It is in the form of a cube minus 27 is 3 cube. It is in the form of a cube minus b cube. What is a cube minus b cube for us? A minus b into a square plus ab plus b square. Okay. Now, so we have, of course, this is f of x. He is saying that f of x greater than 0. Anyway, we will see that later. Now, if you look at the linear factors, 2 power x minus 4, that is the numerator, log x base e, x minus 3, and we have x square plus 3x plus 9. X square plus 3x plus 9, if you observe there, it cannot be further factorized. Why? Because if you take the discriminant of that, discriminant of x square plus 3x plus 9 is 9 minus, that is b square minus 4ac, that is 36, which is less than 0. It means this particular expression x square plus 3x plus 9 has, if you make it equal to 0, it is going to have imaginary roots. Imaginary roots. So anyway, that we can consider it is always positive because x square coefficient is 1 here. X square plus 3x plus 9, if you look into its x square coefficient is 1 and its discriminant is negative. So it always have positive sign. So as it is always positive sign, it is not going to affect my f of x anyway. Now let us see how to solve it. First step is what? We have to find out the critical points. How can you find out the critical points? We have to take 2 power x minus 4 as 0. Thereby x is going to be 2. Because 2 square is 4, 4 minus 4 is going to be 0. So if you take log x base e is equal to 0, that is going to be, x is going to be e power 0, that is 1. And one more thing you have to remember, x must be always positive because log x base e we are writing, it is to be mentioned clearly that log x is not defined if x is negative or even 0. So x is more than 0. Next we have x minus 3, 0. It implies x is equal to 3. Okay. Anyway, x square plus 3x plus 9 is greater than 0 for all x belongs to R. Why? Discriminant is negative and a is more than 0. Because of that condition, x square plus 3x plus 9 is always positive. So for all x belongs to R, we can say it is positive. Now if you plot these points on the number line, what are the critical points here? Here 0 is a restriction. You cannot go beyond 0 because log x function is not defined if you go beyond 0. So that is the case we have to take. Next first critical point 1 let me take. Next critical point let me take 2. Next critical point let me take 3. These are the critical points. So this can be extended indefinitely. Now if you take any value more than 3, if you take any value more than 3, in that case 2 power 3 is 2 power 3, more than 3 means 2 power of, let us suppose 4. 2 power 4 is 16, 16 minus 4 is positive. Anyway, log 4 to the base e is some positive value, x minus 3, that is 4 minus 3 positive. Anyway, this expression is always positive. So here the curve is positive. So this is how the curve moves. This is how the curve moves. So this is plus, this is minus, this is plus, this is minus. Okay? So this region is positive region, this is negative region, positive region again, negative region. Now what is he asking here? He is saying that it is greater than 0. F of x is greater than 0. As it is greater than 0, what is the reason we have to consider? Between 1 and 2 and more than 3. Between 1 and 2 and more than 3. Therefore, here I can say that as f of x is greater than 0, x belongs to, what we can say? Open 1 comma 2, union more than 3 is nothing but 3 to infinity. So x belongs to 1 comma 2 union 3 comma infinity. That is the solution set for the given rational inequality. Okay. So here interesting thing is introduction of log into the picture. Till now what are problems we did? They are only a combination of linear factors. Okay. So but here we have log function as well as exponential function. Both are there in this particular question. Okay. Now we'll move to the next question. Solve 2 sin x minus 1 by x minus 1 times of x minus 2 less than 0, where 0 less than or equal to x less than or equal to pi. We are given x must be in between 0 and pi. That is a condition. Using that condition, what in between what values it is? Negative. That is the question here. Now let us take it as f of x is 2 sin x minus 1 by x minus 1 times of x minus 2. Let us take this. So what are the critical points we will consider here? First point is that 2 sin x minus 1 is 0. It implies sin x is 1 by 2. Sin x is 1 by 2. What are the values where sin x is 1 by 2? If you look into the graph of sine function, if it is 0, this is pi by 2 and this is pi. Okay. So here it is 1. If you take it as 1 by 2, this is how the sine function. This is how the graph of the sine function we have. Sine x graph is that at 1 by 2. 1 by 2 means if you draw a line here, it is going to intersect at 2 distinct points. So they are the solutions. Means they are the x values where sin x is 1 by 2. If you draw the parallel lines to y axis, they meet the x axis at 2 distinct points. They are nothing but pi by 6 and 5 pi by 6. Pi by 6 and 5 pi by 6. So the values of x which are satisfying this condition, what is that? 0 less than or equal to x less than or equal to pi and sin x 1 by 2, or x is equal to 5 by 6 comma 5 by 6. These are the two values that x will take considering the condition sin x 1 by 2 and 0 less than or equal to x less than or equal to pi. Now next thing, if you take x minus 1 is 0, then x is 1. X minus 2 is 0, it implies x is equal to 2. So these are the critical points here. So let us try to plot them on the number line. So here restriction is 0, this is 0. Okay, next we have pi by 6, that is less than 1. Next we have 1. Next we have 5 pi by 6, that is next to we have 5 pi by 6 is nothing but 5 times of 3.14 approximately by 6, which is definitely more than 2. So we have 5 by 6 here. Next we have to end up with pi. So this is a restriction because 0 is 0 less than or equal to x less than or equal to pi is the given condition. So in this interval only we have to discuss. Now let us start with the sine function. How the signs will change. 5 pi by 6 to pi. 5 pi by 6 to pi, if you see, this is the area. In that area, sin x value is less than 1 by 2. Sin x value is less than 1 by 2 in the sense 2 into less than 1 by 2 minus 1 is negative. So here the region is negative. So the curve will move like this. Next, between 2 to 5 pi by 6, it is somewhere over here. It is positive. Next again, from 2 to 1, 2 to 1 is negative. Again it is positive. Again it is negative. This is how the curve moves. So this region is negative region, this is positive region, negative region, positive region as well as negative region. Okay, now what is he saying here? This f of x is less than 0. He is saying that f of x is less than 0. Less than 0 means what? This is the region. Next we have to take this region as well as this region. This combination of these three regions is a required answer for us. Therefore here as f of x is less than 0, x belongs to close to 0. 0 can be included. Close to 0 to pi by 6. Pi by 6 can you take? No, we cannot take. If it is pi by 6, the numerator value becomes 0. But if here the inequality is less than 0, so we cannot take union 1 to 2. Anyway, 1 and 2 also we should not take because they are the denominator position. If x is 1, denominator becomes 0. If x is 2 even, denominator becomes 0. So we should not take 1 and 2 also. Union 5 pi by 6. 5 pi by 6 also we cannot include because for that value inequality becomes 0. Pi can be taken. Pi can be taken because if you take pi, 2 sin pi, that is 0. 0 minus 1 is negative. negative is less than 0, that is true, acceptable. So here the solution set is x belongs to close to 0 to pi by 6 union, open 1 comma 2 to union, open 5 by 6 to close to pi. This is the solutions set where f of x is less than 0. If he is asking f of x more than 0, you have to take this region. Pi by 6 to 1, here 2 to 5 pi by 6. As per the given question, the answer is this. Okay, now we'll move to the next question. Solve x times of x minus 1 whole square times x minus 2y, x minus 3 whole cube is greater than 0. Okay. Here what is interesting? Here the linear factors have powers. Okay. So x minus 1 has the power as 2, which is even. X minus 3 has the power as 3, which is odd. So it is interesting. What are the critical points? Here x is equal to 0 is one critical point. Next, x minus 1 is 0, it implies x is 1. Next, x minus 2 is 0, it implies x is 2. X minus 3 is equal to 0, it implies x is 3. So here the critical points are 0, 0, 1, 2, 3. Okay, now let us try to plot them on the number line. 0, 1, 2, 3. Okay. Now, if you take any value more than 3, suppose we have taken 4. 4 into 4 minus 1 whole square into 4 minus 2 by 4 minus 3 whole cube. Every value is positive. 4 into 4 minus 1, that is 3 square, 9. Everything is positive here. So the curve is positive if you take value more than 3. Fine, at 3. See, this is very important discussion now. Suppose if you take 3 is because of the linear factor x minus 3. If x minus 3 has even power, whatever sign the curve has before 3, even after 3, the curve is going to have the same sign. If it is plus, it remains to be positive if x minus 3 has even power. But as it has odd power, 1, 3, 5, 7, any kind of, if it has odd power, then the sign of the curve changes. Now again you have to check with 2. 2, x minus 2 has power as 1. 1 means odd power. So again the sign changes. Sign changes means negative to positive again. Again at 1. If you take it 1, x minus 1 whole square we have. So x minus 1 has the power as even number. Then the curve sign remains same. Means if it is plus, still it is plus. If it is plus here before 1, even after 1, till 0 the sign remains to be positive. Because x minus 1 has its power as 2. If x minus 1 has even power, whatever sign we have before 1, even after 1, till 0, till next critical point, the same sign continues. That is very, very important discussion. Next, 0 is because of x. Here it is having power as 1, so odd power. So the sign changes, it is minus. So here the signs are minus, plus, plus, minus, plus. Okay, so this is very, very important here. This nature is the special observation in this particular problem. Okay, now what is saying? The inequality is said to be greater than 0. Greater than 0 is in sense positive as as x of x minus 4 square times of x minus 2y x minus 3 whole cube is greater than 0. X belongs to what are the positive regions? 0 and 1 union. Here 1 can I take? So the point is, of course here it is plus, here it is plus. Why am I not taking 1? I am not going to take 1. If I take 1, what happens? X if it is 1, 1 minus 1 whole square is becoming 0. Numerator part becomes 0. If numerator is 0, the entire inequality becomes 0. But he is saying it is more than 0. So 1 should be avoided or excluded. So I am not going to take 1 here. So 1 again, 1 comma 2. Union 3 to infinity. I should not take even 2. If I take 2, what happens? 2 minus 2 becomes 0. Okay, should not take 3. Because if you take 3, x minus 3 is becoming 0. So denominator is becoming 0. That is not valid. So here, the solution set here is x belongs to open 0 to 1 union, open 1 to 2 union, 3 to infinity. Okay, that is the end of today's assignment. Tomorrow we are going to see few more problems on these rational functions inequalities. Okay. That is the end of today's assignment. Thank you. Have a good day.